Bhangra, Bhangra, everyone, come on! Okay, thanks for warm welcome, guys, and great to be here. Maza aa raha hai. So, came show, Gandhinagar. We are having a guest from outside of India, and we should really show the energy in Gandhinagar and Ahmedabad, right? So, show, Gandhinagar. Yeah. All right. So myself, Ashish Tiwari, I worked for Elastic as a senior developer advocate, and today we going to deep dive on how really you can integrate generative AI LLM. These buzz terms these days, and with the PHP, right? Anyone who is already integrated some of the LLMs with the PHP? PHP, okay, you have integrated with the Python? Okay, I can see the more hand with the Python instead of PHP, right? So, okay, we will see by end of this talk, we will see what library we can use it and how easy to integrate, whether you want to build something like a chat assistant, chatbot, semantic searches, the vector search, all of those, the fancy terms these days is going on. All right, so before getting into this, I wanted to, start with a question. What is the funniest prompt you have ever sent to any LLM? You can shout, it's okay. Any? Okay, anyone to generate a code? Okay, how to solve this error? DB connection lost. Anything else? Sorry? Laravel, okay. Introductions, all right, okay, great. So we will simply see what is the prompt engineering looks like with the next slide, right? And so LLMs is the quick introduction. I know everyone knows is just you give some prompt, it will generate some response textually, right? It's nothing but basically it's predicting the next words, right? It's generating in that way. So we got the transformers, we got the you can do the fine tuning, the LLM you can build your own LLM, something like that. But these days, leveraging LLM is way more easier than building our own from scratch. So we got a ChatGPT, we got a JMA, we got a lot of LLMs available into Hugging Face. Feel free to download and just start working on it. But how things works basically. So the prompt engineering plays an important role, right? The LLM works basically on the prompt, and whatever the game you have to play, it is just a prompt. The prompt is the only way, right? There are the other parts like a function calling and this days the agentic LLMs is also there, but we will see how they are works. So every time there's a first prompt is not always going to work. It's happening with you, right? All the first prompt is not work, right? So you have to iterate it, you have to give some more context, you have to add it, and these techniques known as a prompt engineering, how you are fine tuning your prompts, right? And once your first prompt is not working, you provide the additional information that is we call as a in context learning, right? You give the context, right? So there's a different types of ICL, so in context learning, right? So there's a zero shot interference. For example, I love this movie, right? And just classify this review. This is one of the prompt I'm giving to the LLM, and it will give you the response like whether it's a positive or negative. And this kind of the prompts you can use, let's say the text classification, semantic analysis, not a semantic search, NER, whether you give some text to LLM and it will auto label your data. For example, India is my country, so it will automatically going to tag India as a country, right? Gandhinagar is a beautiful place for food, so it's going to tag automatically like a Gandhinagar as a city, like this. So all this operation you can do with the LLM, and it's zero shot inference. You just give once and that's it. After that, the process is called the one-shot inferences. So one-shot inferences is just, you give the one example in your prompt only, right? For example, These are the category: billing issue, technical problem, services request. Now you categorize below problem statement into this particular issue, and you give such a bit lengthy prompt, and the LLM will work accordingly. It will tag your data accordingly. I think it's a fair, easy enough, which we do day-to-day life. So where you can use this is basically text to SQL, right? You are generating some SQL queries, summarize some of the content, and refine the extraction accuracy, and so on. But again, giving the one example is not solving your problem. It's not going to achieve the accuracy, right? So now we got the few shot inferences. So few shot is nothing but, again, you increase your example, right? So this technique is helped when you have to generate a very specific type of data. Let's say JSON, let's say XML. You are expecting LLM to produce the exact response, right? The JSON, especially if you are a developer and you are trying to, integrate with your code. This is the challenging part, right? So sometimes it generate the JSON, plain JSON, sometimes it's come with the backticks, sometimes it's come with the curly braces, not missing, something like that. So in that case, you should give a try to a few short inferences, and it's going to help you out, right? Similarly, as I mentioned, you give some examples, 1, 2, 3, and it's going to generate the response accordingly. So where you can use this, right? Text to SQL, again, because SQL has to be structured. You can't, if you're directly going to fire this query to database, you can't afford the query failure, right? So similarly, we want to generate the JSON, XML, the concise summary, right? I want where the LLM should not use its own knowledge, but it should give the summary on my private data, which I am giving into the context. So in that case, the few shot inference are good. All right, these are the good prompt engineering examples, but what happened next? Okay, still the LLM having some limitations, right? As I given the hallucination bad answers, it's the famous one. All right, these are some of the example, the news you must have gone through it, but anytime if you want to test any chatbot, okay, just type, okay, write a hello world program in a Python and just see whether it's giving the output, then it's doing wrong, right? Similarly happen with some of these brands. So the hallucination is definitely one of the example. The second is complex tech stacks. Of course, creating a LLM, it itself is a challenging. It's demand certain expertise. It's demand a certain hardware, certain infrastructure to scale, to learn, and all those stuff. It don't have a real-time access of data. If I tell you, you want to build a chat assistant on your private data, you can't build it unless you're going to train your, train the LLM with your data, right? And you can't train into real time, exact. So, and the security and privacy concern is there always, and there is a lot of debates is going on around it, security and privacy. So if you are a bank, if you are a public sector, they are still hesitate to use LLMs, right? Cool. But how to overcome this? Anyone? What is the solution for this? Build your own what LLM? The LLM, right? So, but building the LLM again, if I'm not an ML engineer, like, okay, I'm a code developer. I love coding, but not building models. So how are things going to work? Anyone? Fine tuning is one of the good example. Fine tuning. Anyone else? System prompt. Okay, this is we covered in the prompt engineering. Negative prompting. All right. Okay. Sorry. मैं देख रहा हूँ लाइट बंद होने के बाद सब बहुत चिल्ला रहे हैं. But it's okay. Yeah, I loved it. So negative prompt. Okay. And what else? Okay. Have you heard of RAG? Retrieval augmented generations, okay. This comes in a picture where you want to overcome this, and it's come with the challenging as well, but I'm happy to discuss of it. So how the RAG looks like, okay. The retrieval augmented generation is nothing but you dump your all the data into the one of the data source. Okay, it might be a vector DB, it might be any database, it might be Elasticsearch, anything, and whenever you want to hit the query to LLM, that query first it will go to database, whatever the data source you are using. All right, so it will hit with the same query and it will get top 5 or top 10 record which is highly relevant to that particular query. Is it good? Right? And top 5, top 10 document we're going to consider as a context window. So for example, you are asking when the Laracon is happening, that when the Laracon is happening as a query, it will hit to database, it will come with the 5 or 10 result, top 5 or 10 result, that going to the context window, and indirectly we're going to make it a few short inference because it's context, right? And at the end, we're going to send this complete text as a prompt to the LLM. And at the end, we can expect the right answer. Is it good? This is a RAG. Any doubt in this? All good? Okay. So if you want to build a chat assistant these days, right? You don't need to train the LLM unnecessary, right? It's come with the demand, with the effort, time, the infrastructure. Simply you use RAG, and most of the chat assistant these days you see they are powered by RAG, right? So we will see how we can quickly build it on PHP, right? So retrieving documents from a question is the first part. So if you see here, your question will go on a database. This is the first part. It should pick the top 10 result as the most relevant, as the most good matching result to that particular query, right? So here, your search should be powerful. And if you're going to search with the full text search, right, it will come with the result, but it will be not that accurate, right? So you need to use the semantic search, or sometimes you need to use the hybrid search where you can combine the full text plus semantic search both, and it will help you to extract the top 10 or top 5 document, which is highly relevant to this. This is the first, right? The one solution, of course, these days is floating like the vector database. So vector databases are simply you generate the embeddings, you push the embeddings into vector database, and you perform the semantic search. Anyone, what is the semantic search? Anyone? Okay. A wrong answer will get some goodies on Elastic Booth. Does this help?
Finding meaningful words.
Sorry?
Finding meaningful
Finding meaningful words,
words.
okay. That's correct. Anyone else want to attempt? Okay, so yeah, so these days, not these days, but the let's say the few years back, the search was happening with the keyword-based search. Even today's also, it is mostly the keyword-based search. But the semantic search is not going to search on keyword, but the meaning of that keyword. Right? Maybe it automatically relate or generate the synonyms. It can understand the intent. For example, which is the Gandhinagar is a beautiful city, right? And someone is, this is one record, and someone is asking the query like, okay, which city is best or which city is good in India? So it will automatically map the good with the best and the beautiful and the wonderful, something like that keyword, and it will automatically pick that semantic result, right? So this is where the semantic search comes in a picture. So these days, you know, sometime it happens you don't know exact keyword and you are start typing the keyword around that context on a Google and it give the result. So it's nothing, it's not a magic, but it's a semantic search. Right? And this is where the vector databases comes in a picture, which help you to give the vector, give the semantic result. So there is a lot of vector database available, like Elasticsearch, Quadrant, Pinecone, right? And all the open source, you can go and you can integrate with your applications. All right. So what is vector? So the vector database is okay, but the database, you store something that is called data, the database, but what is a vector is? So vector is nothing but you give your text to LLM, it will generate some arbitrary number. For a human, it is generate some arbitrary number, but for the machine learning engineers, it's mean something, right? And the vectors, if you remind of the maths, okay, so it's come with the array of floats or array of numbers, and which is useful for the machine learning model, which is generated by the LLMs, correct? So simple. Let's keep it simple. Up text do, it will generate the numbers. That's it, right? And we call it as a vector. So if every model having a different dimension, so the Llama 3.2 having a 3072 dimension, which means 3072 numbers it will be there into array, right? So it's depend on LLMs which you are using. So yeah, and you cannot just generate the text, but you can also generate the embeddings for image. So if you want to build the image search, right, like a Google image, you put something, you put a face, and it should search the relevant images. You can build it, or probably you can you search on the e-commerce like a white shirt with one pocket, something like that, and it's give the relevant result. You can build with the help of vector search. So yeah, you can convert the vector of text, audio, images, audio as well. So sometimes we don't know the lyrics of audio, but we remind the tune, and just you just do the hamming, and it will convert that audio into vector search, and it will search for the particular song. So all three is possible to generate the embeddings for it, and you can perform the search on it. All right. Any doubts so far? All good? All right. But how this search is happening, okay? So for example, you have given the 1000 record, and it's going to generate the 1000 equivalent vector array of numbers or array of floats. But how the search is exactly happening behind the scene is because of the similarity algorithm. So there is a similarity algorithm is a cosines, dot product, and Manhattan, and all those stuff. So if you see it's going to group all the similar embeddings. For example, child, infant, girl, boy. That vector is going to sit next to each other, so that if someone is going to search for infant, it's going to search all the nearest neighbor, like a child, girl, and boy, and it will give it to you. Now let me give the example in e-commerce fashion. So if you're searching for red shirt, okay, on any e-commerce platform, it's automatically give the maroon shirt, right, orange shirt, because it's identical to that color, red, right? So recommendation-based system you can also build with the help of the vector search, right? So, but the only thing is the embeddings you have to generate it, and this is how this embeddings store or save into behind the scene, right? So there are many techniques, and LLM typically this is done by the neural network. So this is a projector.tensorflow.org. You can go and you can check how these things works, right? So the goal is to group the information, the similar information, and whenever someone hitting this particular keyword or particular the word for a search, it will generate the embeddings on fly of the query as well, and it will do the vector search, and it will do the vector search with the help of those algorithms, dot product and cosine similarities and all those stuff, correct? All right, let's jump on a demo, right? Any doubts so far? Okay. So we're going to use the Elephant. Elephant is a quite famous library. It's an open source. If you are building the Gen AI application, right? You want to build the question answers, you want to perform the vector search, you want to do the semantic retrievals, you want to do the re-ranking, all those techniques, it's available into the Elephant. So if you have noticed that these days the Pythons are much popular to building a Gen AI application, but yes, you can definitely do with the PHP. And the RAG itself is it's a concept. It's not something else, but it's a concept. You can make a RAG, you can build a RAG in any language, to be honest. All right, Llama, I'm going to run the Llama 3.2 model on my local, and I'm going to run the Elasticsearch on local, and we're going to use the Elasticsearch as a vector database, so that all the semantic search will be going to perform on an Elasticsearch, and at the end we going to send all the few shots prompt to the Llama 3.1. All right. Um, Before that, the Elephant is open source PHP generative model supported is OpenAI. If you're looking for the GPT, so just go for the OpenAI, Mistral, Anthropic. If you wanted to host your private LLMs, go with the Ollama. Great support of VectorDB. There's Elasticsearch, Chroma, Quadrant, Melvis, and etc. Support embedding generation. So here's the thing. So if you're going to build the RAG from scratch, so the embeddings generation you need to take care of, right? Similarly, the document chunking is again the one of the challenging part. So for example, if you have a large PDF available, right, you can't read the large PDF in one shot and insert into Elasticsearch, right? Because you need a memory and all those stuff. But you also can't consider the complete PDF document as a one record. You have to chunk it down. Maybe you need to consider the one page as a document, one page as a one record, probably the one paragraph as a one record, probably the fixed length of character as a one record, so that we can perform the search query over it, right? So all the document chunking, semantic search, and the embedding generation will be taken care by Elephant. And at the end, you can do the question answer capabilities. You can build the question answer capability, which is nothing but the RAG, right? So what we're going to do is, I'm having a one PDF. I'm going to pass that PDF into Elasticsearch by using the PHP and Elephant library, and we're going to ask a question on that data, and in a natural language query. Okay, it's like a chat assistant, and let's see what the response it will generate. Okay, before getting into that, the Elasticsearch I have given. So anyone is using, and I met a lot of folks who are using Elasticsearch, but who's using Elasticsearch? Wow. All right. So the Elasticsearch having the vector capability as well, the vector search, the semantic search. Go and check. It's open source, right? You can run on your local and get started. Just dump your all the embeddings and perform the vector search over it. It's a distributed search, analytical, search engine. You just dump your data if you are dealing with the petabytes, terabytes, and you want to perform a very quick search. Just one single query, and you will get the relevant result from it. So let's jump on demo, and then we will see how things looks like. So what we're going to do is, we got a PDF, we're going to chunk it down in a smaller piece of data, and we're going to pass first through Llama 3.1 so that we can generate the embeddings, the large numbers. The numbers we going to store into Elasticsearch, right? So this is the ingestion part. Now the reading part. So whenever we're going to ask a question like, okay, who won the Nobel Prize in Physics in 2024? This query will first hit to Elasticsearch. It will come with the 4, 5, or 10 result as a context. It will perform the semantic search over it. It will come with the relevant data, and then we're going to send this to the Llama 3.1 again, so that we will get the answer like the chat GPT experiences or any other LLM experiences, right? So we're going to generate a response like that. All right. Any doubt in this flow? All good? Okay. So this is the PDF how it looks like, right? It's a Nobel Prize Physics. So if you see, it's images, there's a text. So right now we are going to work on text only, but definitely you can pass the image and you can generate the embeddings for it, correct? Okay, let me go to my terminal. All right, let me zoom this. So this is the Elephant. I already cloned it. If you go to here, this is library. You can just clone it. You can do the composer install, whatever you feel free. And I just clone it, and I'm going to run here. So I have built the one script called embedding.php. So how this thing looks like is I have included all the elephant. This is my model, Llama 3.1 8 billion parameters. I'm here reading the PDF file. If you see here the document splitter, it's going to perform the chunking operation, right? And how is going to chunk it? I'm going to chunk on every 800 characters. So here I have defined, if you see, the 800 characters. Yeah, you're able to see this, right? So, and once it's done, then it will embed the document. I have just creating the Elasticsearch connections, and it's going to store into Elasticsearch. So this is our ingestion part. So let's run this first, and let's see, this is my Elasticsearch is running on my local. So if I go here, and earlier for the install the Elasticsearch on locally, you have to install the Elasticsearch and Kibana separately. Now this is a one command. You just hit it on your terminal. Just the only condition is we need a Docker. Just hit this command, and the local cluster will get ready, and you can use it. So, right. So I'm already running it, and this is the default page. So it's running on localhost 5601. So it's a huge world. I mean, the observability, security, probably we can discuss later, but let me simply go to the dev tools. So in Elasticsearch, everything is an index. It's JSON, right? So all the data we are going to store into the JSON format. So let me run this first, and let's see. So what it's going to do is it's going to insert the data into the index called the novel. So it's reading, and it's passing it, and it's going to store into Elasticsearch. So the total number of chunk is at 24, which means there is a 24 record is going to insert into Elasticsearch, right? Let's verify. So in Elasticsearch, everything is a REST, if you know. The reading a data, writing a data, the modification, everything you have to use the same API I'm using. So this is my index name, and this is my search I'm hitting. And if you see, this is how the data looks like. So now if you see the embeddings, these are the numbers, the vectors I was talking about, right? So how we are storing the data here is the numbers and the plain text of that particular chunk. So if I need to show you how the plain text looks like. Yep. So if you see, this is the content, and it's chunked on every 800 characters, and it's been stored, right? And so I have just selected content to show it, but it is also stored the long numbers, we called it as a vectors. So let me show you that as well. Yep. All good, right? So the Llama generated the 3071 dimension. So this is the 3071 number for one record, right? All right. So let's now the ingestion part is done. Now let's ask some question to it. Okay. So there's another script I have written is question answer. So I'm importing the elephant, connecting with the OLlama. So OLlama is running here. If you see, sorry. All right. So this is my models are running on my local. Okay. Now. It's reading some configurations, connecting again with the Elasticsearch. So if you see the question answering, yep, this part. So if you see the question answer, this API itself of the elephant is going to perform the RAG. which means it's automatically going to hit the search. It will come with that. It will create the LLM. It will pass to the Llama 3.1, and it will generate the response. So your life is easier, right? Earlier, so if you building the RAG very raw from the scratch, you have to perform all the steps individually. Okay, so now it's time to perform some question answer. So the first is, who won the Nobel Prize in Physics in 2024? And here I'm giving the number of record I should extract. Is it 10? So let me run this. Let's see. All right. So if you see, this is the first response. This is a response from the LLM, right? And this is the search result. I just print for our understanding, but the actual response is this. According to the text, the winner of the Nobel Prize in Physics for 2024 are John and Geoffrey. So similarly, and what context we have given? We have given this 10 document, the 10 relevant document which been extracted from Elasticsearch. All right. The quick. So let me try something else as well. How brain neural network works, right? All right. Yeah. So we got the data. Now, according to the text, an artificial neural network is blah, 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 and in giving the response. And it's giving the response from this 10 document. So here, it's not using its own knowledge, which has been trained on. Okay, it's using this top 10 document only. All right. Now, similarly, the last question, let me ask, okay, who won ICC Championship 2025? Today's, okay. Surprisingly, it should not come. Yeah, the India is winning, I know, but that is the whole purpose. It should not give the answer out of context. Otherwise, this demo is going to fail. Okay, I don't know. The text provided doesn't mention the ICC Championship or any information about the sports tournament, right? So if you want to build any chat assistant like this, go check with the RAG, and it's very easy. You can perform it, right? All right. Cool. All good? Yeah. Okay. Thank you. And these are some of the references. If you want to get started with how things are working, LLMs, some of the reference which I use in slides, Elasticsearch as a vector database, and why we are best database. You can come on a booth. We can have a good discussion about it. The search relevance, right? How you can tune your search performance. Everything you will get it into these references. And feel free to go and check it out. And now that's it from my side. Thank you very much. Yeah.
Hello. Yep. Thank you, Ashish. So I have more than 77 questions.
Oh,
but since we are running out of time,
okay,
maybe if I check right now, it might be more than 80.
I'm going to revert everything. Don't worry.
Yeah. So I'll ask only one question.
Yep.
Because the time is the key for us.
Sure.
So the question is from Sachin Parmar. If you are there, please come near the stage. He has an interesting question.
Yeah.
His question is, when we talk about Gen AI, the main thing is speed.
Mm-hmm.
So can we expect the same performance with PHP for LLM, which we generally get using Python?
Okay. So when you, the speed related question.
Yep.
When you say the Gen AI speed, the speed is really not lies into language, especially the Python, PHP. That is okay. The way how the speedful is the LLM is to generate the response. Okay. This is where the GPUs and these, the TPUs, you need to use it to do the better inferences. Correct. the even in the RAG, if you build, doesn't matter you're building in which language. Let's say the Python, PHP, and everything. So the vector DB is one of the latency part. It should be a fast enough to get a chunk. Second, your LLM at the end, it should be speed enough to generate the that particular response, right? So for that, there is a optimization. You need a better hardware. You need a, there is a penalty. You give the better context and other some of the techniques to optimize it. But the speed is really a matter with the LLM. So this is my take.
Yep.
Yeah?
Perfect.
Thank you very much.
Thank you, Ashish.